McCormick School of Engineering. And more interestingly to me, at least, he's also an artist, and he's going to talk about creativity and art and science, and looking forward to it.
Okay,
Thanks,
great.
Julian.
Thanks, Ed. Okay, so can you hear me okay? So I want to thank Ed for coming up with this. Basically, the main reason for being here is I want to float some ideas because I'm organizing thoughts for a book.
Need a lapel mic.
So what I want to talk is about pretty ambitious, is about art, science, technology. So how many of you have this program in design? In technology, computer science. So what I want to do is basically the biggest domains of organized thought. So it's still from generation to generation by humanity are contained, this is by no means all information, are in the domains that one would call science, technology, the overlap, and art. And what I want to do, if I should stay here, I presume. Okay, that's good. So I presume you have discussed like 1 million times in here, okay? But this is my own little list. And I haven't done an extensive study on the catalog, let's say, of universities, on how many things you could do in 1940, 50, 60. It will be an interesting exercise, but there is no question that the range of things that you can do is increasing probably exponentially fast. And the list of professions. But at the same time, that's bullet number 1 is sort of contradictory with bullet number 2, because bullet number 2 more or less tells you that some of the most interesting stuff going on there happens at intersections between boundaries. So part of the motivation for me doing what I'm doing is because I think that there is a need, given how bifurcation of things are taking place, to help organize thoughts on how people could navigate these intersections. So what I'm going to try to tell you is some pretty broad concepts about in what ways to facilitate this exploration of the in-between spaces, okay? Now, this has been going on forever. I mean, if you want to see in a written form something that encapsulates all 3 domains, you have nothing more to go and look at in La Biblioteca Ambrosiana in Milan, look at Da Vinci, the Codex Atlanticus, it's all in there. And then there are people who have talked like C.P. Snow about the 2 cultures between science and art. And I was trying to articulate something in this area about what should sort of be my mission in here. And I came across this. This is the title of a journal called Transformation. And the sort of manifesto behind this journal was that I'm taking this verbatim and leaving lowercase where it was lowercase, the dots, trying to copy it as faithfully as possible. So the goal of this journal, Transformation, was that art, science, and technology are interacting components of the total human enterprise. But today, they are often treated as they were cultural isolates and mutually antagonistic. Transformation will cut across the arts and science by treating them as a continuum. Now, the interesting thing is that this was in 1950. And this guy, Harry Holtzman, who actually had a long life, he did this in 1950 and he died in 87, this attempt to do this blurring, guided tour of this area lasted for only 3 issues. So there are only 3 issues of this journal. But look at the people that he invited. This is a random list of people who contributed to those first 3 issues. I'm pretty sure that many of you will recognize 70%, 80, probably all of them, okay? There were a few misses, but this was in 1950. It was not a given that all of these people will be so famous today. So I'm going to leave, basically, Harry Holtzman didn't have a really distinguished career. His main claim to fame is the guy who organized the trip of Piet Mondrian from Europe to the US, got the visa, got an apartment for him. That's what he did, okay? So this is my objective, is a little bit how to navigate this landscape. And I had a series of slides at the beginning that they were, I don't know, covers of Nature and Scientific American and Efficient. That's the stuff that I have done. And all the paintings that you saw were stuff that I have done, starting pretty early when I was 15 or 16. So it's not that I will say I'm the best person to talk about these three things, but I see when I talk with people who are in the art, sort of middle of the Gaussian in the art, how misconceptions they have about the technology side. So I'm in here to do a kind of a systems view of this, and I will kind of refer backwards a little bit. I'm not going to refer backwards. Well, I refer something from the 13th century, but most of my reference will be, I don't know, 1890, 1970 kind of things. So I will tell you that I have some reservations about this. I'll drop some comments about math. This is G.H. Hardy, probably one of the greatest mathematicians of the 20th century. And he said that there is no score more profound or on the whole more justifiable than that of a man. There are several quotes that contain the word men in what I'm doing, okay? They are old. That of the men who make for the men who explain. Let me just... Exposition, criticism, appreciation is work for second-rate minds. So it's not that I believe that that's true, but I have some degree of apprehension in coming and explaining things, because at the end of the day, this is explaining. Although every concept of what I'm about to tell you, I haven't really copied it from any place. They are my own ideas, okay? So the central concept that I will have is, and behind this is kind of like the outline of a book in some sense, okay? The book will be a conventional book in the sense that there will be chapters that will be the main notes, but then there are kind of secondary notes, of which I'm putting about a third in here. These are things in which you will look across on how these three domains are, and then I will look at several of these. I probably will skip several of them, and at the end, try to distill some lessons, and the lessons that I distill will go more or less flow from art to science and technology, okay? So this is part of this table. In this table, I pick something like this, and then try to expose that. So the central aspiration of art is creation. I'm simplifying. This has to be one word. Technology is invention. Science is discovery. Just to get the terms out, Hamlet was created, the light bulb was invented, the DNA was discovered. And if you want to put two words to define each of these things, I would say science is explaining and unveiling. You lift a veil and you reveal something that was already there. Technology is making and building. Art, say creating and expressing, but I know of no artist that will tell you that what they do is creation, okay? Is a given. So a word that probably will be more apt for at least many of them will be reframing, that they force you to look at something in some different way. So let me start with a few comments about the art side. It's kind of like a random walk for people who not may be in this sphere constantly. So this is Gerhard Richter, famous German artist. I think what is interesting is the same guy who did the thing on the left was able to do the thing on the right. And the right is also a painting. It's not a photograph. Then you have Anselm Kiefer, also German, gigantic installations. This is one of them. This is one of his paintings. Then you go to people like Jeff Koons, in which art is more like the head of a factory. And you may have seen things by him. And then you have a guy who is almost trying to change the equation of artist, dealer, Damien Hirst, English, did also this thing that you may have seen on the news. All of the stuff in there are diamonds. And then you see things like this. This is a colleague of mine, Michael Rakovitz, and this is in a museum, so it must be art by definition. But actually, if you see this on site, this is what that is. Inside there is a homeless person. So the fact that art should not be useful, this kind of sort of is a counterpoint to that. Now, if you are coming from the side of art, and I have to explain math to you, I would use probably this quote. Many of you will know this guy, Fields medalist, is in the advanced studies, says, my attitude towards math is that most of it is lying out there, sometimes in hidden places, like gems encased in a rock. You don't see them on the surface, but you see that they must be there, and you try to imagine where they are hidden. Suddenly, they gleam brightly in your face, and you don't know how you stumble upon them. Maybe they were always in plain view, and we were all blind from time to time. And I would say half of the mathematicians out there, they sort of subscribe to this Platonistic view. And I think probably in theoretical computer science, you'll find kind of similar type of sentiments. But the same idea applies. This is a much shorter quote from Michelangelo. The marble not yet carved can hold the form of every thought the greatest artist has, and even extends to literature, in which, according to people like Jorge Luis Borges, from very fantastic writer from Argentina, is one of my favorite ones. I'm from there, by the way. He argued that the act of writing was actually discovering, not invention. And by the way, is mathematics invented or discovered or created? So it's not. So as to age, this is the simplest one. You can argue that art is as old as humanity itself. This is the Lascaux paintings or caves. Technology, well, the Romans will build in aqueducts before the laws of statics were in place, or the dome in the Pantheon in Rome before all the science was there. By these standards, science is kind of a baby, because it's probably about 500 years old if you have to signal the birth with Galileo. The methodology. In science, there is a method, but I would say that the biggest discovery of science is science itself. There is a misconception that the scientific method, if you go and ask there, governs the growth of science. I mean, it governs at most the growth of experimental science. The way that one goes about science on the theoretical sphere is by induction. And I have this, again, a quote from Jacob Bronowski. I mean, the idea is anticipating things in which there was no grounds to believe that that will be the case. Technology is driven by results. If there is science, you'll use the science. If there are gaps, you'll have to fill the gaps. And in art, there is no prescribed method. Now, how do ideas get incorporated into a domain? A domain, by the way, and these terms come from people in sociology, a domain is all the distilled knowledge that exists in the form of books, papers, subjects, objects, that kind of thing. The domain will exist if all human beings were wiped out of the earth. The field are the people who practice in that domain, a domain being, let's say, algebraic topology, or condensed matter physics, or etchings in art. The field is what decides if something gets incorporated into the domain. And the idea gets incorporated when something at the intersection of the person or a group, the domain and the field, determines that the domain should grow. Okay? An example of a domain growing, this was a mosaic in Hagia Sophia in Istanbul, 13th century. Within what looks like a blink of an eye, Giotto appeared. Giotto was the first artist basically known by his own name. Before that didn't happen. And this guy was the first one who painted the sky blue. And basically, you could say, is the guy who discovered depth. Everything was flat. Okay? So I would say that altered the domain of painting or visual arts. So a domain will grow basically in two ways. Either you discover an answer to a problem that was already formulated. Physics, math are the fields where they are the most formulated problems. Everybody knows what the question is, people do not know what the solution is. Or can grow by discovering a problem, in which case posing the question is as important as finding the solution. But that's basically how domains grow. In order for the domain to grow, and I put, rather than breakthrough, I put break with, is because in order for the new idea to form part of the accepted set of ideas, you may have to break with something that was part of the domain. So in art, the field will grow because the guys in the Tate Modern decide that something belongs there, or in the MoMA in New York, or a more local example at the Art Institute of Chicago. In science, you know that you have made it when you get inducted into the National Academy of Science. What you have done is part of the domain, okay? But the domain is full of final pictures. When you get a paper, you don't get all the drafts of the paper, you get a paper, you get objects in there. And in science, those objects and the linkage in between those objects is traceable in some sense. You look at who referred to whom, where the ideas came from. In technology, it's documentable to the extent that there may be linkage of patents. In art, it sounds magical because suddenly out there appears, but it's in fact probably the most traceable. So in literature, theater, opera, architecture, you see final pictures. Also in scientific papers, in products, you don't see the sweat. In visual arts, I would argue that is the one in which you see the evolution the most clearly. And in fact, that's what museums do. So I picked this example because I was there about 2 weeks ago. It's in Madrid at the Reina Sofia Museum. And this is one early sketch by Guernica from Picasso. And this is one picture. When Picasso was doing this, his mistress was a woman named Dora Maar. And Dora took photographs of the painting as it was evolving. And this is another thing, and this is the final one. And with Picasso did 43 sketches of this, and remarkably, all survive. In visual arts, that matters a lot. No one is interested in every draft of a paper, but in visual art, everybody is interested in every draft that led to the final picture. So now people would argue, and I will touch this briefly later on, that in very logical subjects like math, you could trace how an idea evolved. That's really not knowing much about math, because if you're in the know, Hadamard, who wrote a lot about this, and wrote about the psychology of mathematical invention, Gauss and Riemann, for example, you can read something from beginning to end, and everything is perfect, and the conclusion is something that you have to accept. But there's no trace of the path that they used to lead to the inspiration of why they did what they did. Helmholtz had the metaphor of how you go achieving a final result in a very tentative way, going through a shaky ladder. But when you're out there and finally you nail it, you present it as the smooth royal path. Wittgenstein had another one much shorter, and he said it's about kicking the ladder. Or the quote that I really like is this one by Einstein: the secret to creativity is knowing how to hide your sources. And in fact, it's not that you try to hide it. It's that when you present a result in a paper, no one is interested in how everything occurred to you. You try to put it in the most clean, concise, elegant way. Now, sometimes it's better not to hide. Now, Maxwell, who is now regarded as the purest of the pure among physics, when he was arguing about why it was pointless to try to calculate the trajectories of an Avogadro's number of particles, if you go and read his collected works, the arguments that he was using for why it will make sense to argue in terms of averages and the constancy of averages, he was picking all the stuff from this guy, Quetelet, who was trying to do one of the many attempts to put social interactions on par with Newtonian mechanics. The ones who may be interested in this is in this paper by Philip Ball. Now, there is a sequence to technology, and this is one of many, but the sequence is not like this. First of all, in art, when I show you Picasso and Guernica, and I could have shown like 50 other examples, is one person. Sometimes a curator of an exhibit will mesh two, Gauguin and Van Gogh. Technology, and I don't have to tell you this, is much more haphazard. There are lots of big interruptions in there, lots of people who come right and left, but eventually, sort of macroscopically, you see the evolution as well. Now, as to how things grow, basically, there are two ways in which they'll grow. Either two ideas get combined or more to form a new one, or an idea bifurcates and produces two different ones. And by that, I mean that you start with a concept like, we have uncovered how DNA can unfold and do this and that, and then you study consequences, or you can study consequences from there, many of them. But the thing is that there was a convergence to get to a final distilled picture on the theory side or some fundamental experimental thing, and that led to this wealth of divergence of ideas. Now, I'm not going to go all of this, but I'm just showing you some of the things that will be worth exploring in parallel. And by now, one conclusion that you will get is I put art, technology, and science. And by any metric that I have looked at, technology always falls in between science and art. Almost, always. For example, how the ideas evolve, the chronology, the possibility of time ordering events. For example, if I show you this in art, and I ask you, put all of these paintings, there is a Kandinsky, Cézanne, Léger, there's a guy of name, what's the name? I'm trying to remember in here. Boy, I'm blanking out. Fenninger is probably the least known guy, the one next to the... Jack Close is the woman in the middle. If I ask you to time order these, there is another one by another guy, I will not tell you the names, another one. Put them in order. It's very, very hard unless you really know about art. You can be very bright, but just by asking questions, you will not be able to do that. However, if you are coming from outer space here, and I ask you, order these papers from these random journals, put them in some kind of order. In science, you can time order things. But there is no inherent arrow of time in art. Something that I also should mention is the uniqueness of the product, because this is what gives rise to a lot of misconceptions. And I'll give you one. Art, generally, we can argue that if Shakespeare had not lived, we will not have Hamlet. In fact, Kant made a comparison in between how much creativity was inherent in the work that Newton had done and compared that with Homer and put artistic creation on a much higher plane. And this is something that still persists today. In fact, in this quote, Bernard Cohen was a professor in Harvard. He said this, which is still a misconception. I don't agree with this. I think that there is a style in the way that a theory gets put together. But that has to do with the uniqueness of the product. I think there is uniqueness certainly on the science side on how something gets manifested and put together. Something that I will tell you about where is the creative skill. I mentioned this because I mentioned in here about the intellectual protection. Something that doesn't get mentioned, but in science, the intellectual protection is basically you put it in the open. So science was open source before the term open source was invented, really. But I wanted to make this brief detour in here on Renaissance drawings. So this is in El Prado. I was, as I said, mentioned 2 weeks ago. And this is another one. This is by a fellow named Pontormo, an Italian. And primo pensieri means the first thought, okay? The first thought was what was the most prized skill in Renaissance paintings, because based on this first thought, there was something that evolved in what they will call il disegno. In fact, this may be one of the first uses of the word design. Based on this, putting some grid on top of this is what eventually will result on, I don't know, an altarpiece will be finally put together. The primo pensieri and finally the design had legal force. It was basically like the patent protecting the design of that thing. And that was the most prized skill at that time, which is not the most prized skill now in how we judge Renaissance paintings. Pipelines. Again, I'm not going to go into much detail on this, but the pipeline for science is extremely well developed. There are virtually no outsiders in science now. There used to be more in the 1800s. After all, Fermat was not trained as a mathematician, let's say. Technology, the pipeline is much more or less formal, and in art is very informal. In art, you could argue that there are lots of outsiders. There is no place that says, oh, you're an artist now. You could be trained as one, but that doesn't mean that you'll become. And the other thing that there is an equilibrium is in between the field and the domain. In fields that are well constructed, like theoretical physics, the claim that someone could make as to what constitutes a new thing in the field is dominated by the field itself. However, let me skip this, even the complete outsiders. But when we say, for example, that Van Gogh was unrecognized in his lifetime, or that this guy, William Adolphe Bouguereau, who was the French in the 19th century, they were fond of making surveys and statistics, and this guy, who lived at the time of Degas, was, by a claim of the critics of the time at that point, the most famous painter of the time. And no, we don't really, I don't know if any of you know him, but it's not really a central figure now. So what we basically are saying is that, by the way, there's something really interesting as a sideline, how reputations change after death. So, for example, reputations in math and physics don't change much after death. I mean, you can say that someone has been unrecognized, and suddenly after, I don't know, Galois died, we discovered what he had done. But those are in a blue moon. In art, since the field is so important compared with the domain, you have very big swift changes in reputation. So, for example, this guy, Carlo Maratta, was the most famous painter when Bernini was alive. He's kind of nowhere to be seen now. Vasarely, who was the painting of very geometric that I showed when I said about time ordering, is basically not regarded as one of the guys who will be in the pantheon of great artists. There's some minor switches in, let's say, physics. Pochendorf was the editor of the Annales de Physique, let's say when Einstein was publishing, and the power that he had resided on the power that he had on deciding what was going to be in there. But the guy is not anywhere in the pantheon of great physicists now. So what we say when the field is the overriding judgment over the domain, we basically sometimes override the judgment a posteriori. So, for example, reputations are revised in art sort of constantly. New people get elevated and people get diminished. That doesn't happen on the science, and certainly doesn't happen on the technology side, which is, technology is the closest that it comes to a complete meritocracy, because the field is everything out there. So, definitions of lines of mentorship. Well, in science it's very clear. It's who advises whom. In art is very informal, the thing. I'm doing a study now, this is on the side with one of my students. The most complete genealogy out there of lines of mentorship is in math. And in there you see that Euler sort of advised Lagrange, and Lagrange, Fourier, and Poisson Dirichlet, and Lifshitz, and you go on and on. And a question is, are there paths in there where everybody is great? Could greatness emerge from some place where people are not advised by great luminaries? So we are looking at this now. Another one is the possibility of one-hit wonders. There's very low probability now of hitting one big thing in science. Probably in math, maybe once. Technology, moderate. Art is very low in visual arts. No painter is known by one painting. But in literature, there are many people who fall in the category of the one book wonder and then nothing else. So one conclusion is that if you look at the degree of entrepreneurship, the ability to fly without a net for a while, art, you could argue, is the most entrepreneurial of these three activities, because the pipeline is not very supportive. Clearly, there is no money until you hit the end. And something that kind of cuts across, this is a quote of a quote, but it's something that applies to art and applies to science a lot. So this guy was referring to something that someone had told this person, said, never forget what I believe was observed to you by Coleridge, that every great writer, a great and original writer, in proportion as he is great and original, must himself create the taste by which he relish. If you don't do that, the ideas will never form part of this permanent domain. You have to make sure that the domain is ready to accept this new thing. And this, in art, when people take the long view, I'm quoting Borges in here, the fact is that all writers create their precursors. Their work modifies our conception of the past, just as it's bound to modify the future. When you form part of the canon, the fact that you get inserted in there doesn't modify the forward part, it modifies the backward part as well. Environment and timing, fitting with the canonical knowledge of the times. I'll give you something which is my own thing, and this is one example. There are many, many examples, but I'll just tell you this because I found this really interesting. If you study physics or engineering, you came across this guy Reynolds. He's the one of the Reynolds number. Reynolds, within a year, wrote two things that had to do with kind of mixing. One that was completely statistical, that gave birth to everything connected with the statistical theory of turbulence, in which at some point in the development of things, people will write ergodicity will be part of this, although this is homogeneous isotropic turbulence, something in which no pattern could or should exist. Okay? The other one was completely geometrical. This one he presented in a meeting of the Royal Institution, appeared in Nature. I bump into this completely by accident. When I get stuck, I used to go and look at all the stacks of Nature just to get inspiration. I discovered, by the way, that Reynolds had died, and they were the obituaries in consecutive issues of Nature at the same time of Poincaré. And Poincaré was, there's a long, long story here, and if Poincaré and Reynolds had connected, something could have clicked. But the fact is that the math was not ready for the geometrical picture. It was sort of semi-ready because you didn't need that much groundbreaking math to do the statistical theory. So when I came across here, I discovered that there was this guy, Stephen Smale in Berkeley, who had created a picture that was the Smale horseshoe, and the math was ready for me to use. And within, 6 months, I was in the cover of Scientific American and Nature, and I got lucky. But going through the other branch, and this is what mystified me when I was doing my PhD thesis, there were 80 years of mixing without pictures in journals. It was because of the quote that appears in there, because the point that I'm trying to get across in here, an idea has to fit the canonical knowledge of the times. And for that to take root, besides the physical picture, you need the appropriate supporting math. And if you don't have that, then the idea will not flourish. Groups. I'm going to say very little about groups. Groups sometimes get formed. The futurists in Italy, they tried to form a group in a blast. A very famous group in art, one that had tremendous influence given the fact that they lasted for only 14 years was the Bauhaus. So I'll give you, and to what extent ideas can emerge from groups. I'm not going to go into much detail about this. You probably heard about this law that the Fourier transforms was not developed by Fourier, and Lagrangian method in fluid mechanics was not done by Lagrange, that almost everything is misnamed, okay? So there's this Stigler's law that no scientific discovery is named after the original discoverer, and this applies to Stigler's law also because this was coined by a guy named Robert Merton. But on teams, there's a lot of work, and I'll tell you this because it came from my own institution. It's very easy to study teams where there is a clear outcome as to the result and what the team was. So one of the, and this is kind of like a footnote in here, a clear small team producing something is Broadway musicals. You need about 5 people to produce a Broadway musical, a producer, a librettist, whatever. And then you have the outcome, how successful the play was. So these guys look at this, and conclusion 1 was not that interesting. You needed a mix of people. The second one was much more interesting, and that's why I mentioned it in here. You had to have 2 experienced people, but these 2 experienced people, it was best if they had not collaborated with each other before. The longer the team tried to repeat past successes, the impact diminished. So let me now go to the end in here and give you a few, I would say, cross-cutting lessons. This is mostly from the art side, how they, if you won't regard the art as a metaphor for the lesson, most of these will be things that you know. So the first one is start with a solid grounding. No way around this one, okay? And equate creation with hard work. So here we have someone who started classically trained, did this, then did this, and this was Picasso. So Picasso started very classically trained. This other guy started here, and then this was William de Koning. And I think that this is a really important lesson, in my opinion. And there's this phrase in Italian, I do not know who said it first, okay? It's impara l'arte e mettila da parte. And this says, learn the craft and then set it aside. Because if you become a slave of the craft, you'll never do anything new. Now, as to the hard part and the productivity, let me just flash some numbers. Leonardo, 7 undisputed paintings. It's the record for someone who is recognized in visual arts with the least number of paintings. Vermeer, very few, 36. Rembrandt, 630. Van Gogh, 900 in 2.5 years. Picasso, 13,000. Now, learn how to thrive with constraints. I'll mention something in here. It's not from the art, but it's something that I'm close because something that we have done. It's an HIV diagnostic kit. So in order to make a diagnostic kit for HIV, you need, I don't know, red blood cells, you need to break them apart, you need to collect the DNA, to get the junk out, then you need to put the clean DNA in an appropriate chamber with an appropriate solution, and then you run a PCR reaction. So it involves a lot of fluid handling, okay? But the idea here was that this kit had to be used in Africa. It couldn't be fancy microfluidics. So someone made a decision early on, say, let's try to do this without moving fluid. Sounds like there's no way on earth that you'll be able to do it. But the solution was, put the cells, break them by having an appropriate solution, have the DNA strands collect on the surface of tailored particles. All of this will be an aqueous solution. On top of that, this is a schematic, there will be an oily solution, and then drag the particles, because they are magnetic, through the oily solution to where it says fluid 3, where the reaction will take place. And so this is sample, the particles are magnetic, the particles move, and then you write the reaction there. And voila, instead of using microfluidics and Affymetric and all of that, you can do this for $1. And the result of this was to put a constraint into the problem that made the solution almost impossible. Learn how to adapt. Okay, this is Picasso, and you can see how he did this. This is a piece called Baboon and Young. It's in the MoMA in New York. And there is these terms, and adapt and adopt. Okay? But I think this applies to a lot of things, certainly applies in technology. Okay? There is a very big difference between copying and outright stealing. Stealing, you kind of, the idea becomes part of a bigger idea that you have. Do not converge too quickly and step back and look at the entire picture. There are many solutions that are arrived, and it kind of pays to look, did I get the right one when you think at the end? And this is a very good example. This is a Picasso painting, is in the Art Institute in Chicago. The story is that a fellow who owned the painting was visiting Picasso in his studio in France and mentioned that he had this. And Picasso said, oh, well, that's interesting. When I was thinking about this painting, initially I had something else in mind. And at the last moment, I decided to change the painting. I had a man on the left that was holding a fish, and the baby was trying to touch the fish. By the way, if you want the piece missing, I'll give it to you, and the Art Institute has it now. This idea that you arrive at something, you step back, look and decide if that's what you wanted and change it, is not something that gets done all the time, but is something that, in my opinion, is essential. And let me just finish with what I think is the most important lesson, and you almost have to train yourself to do this, and it's the see simplicity in complexity. See, go from something simple to something with all the flesh and bones needed, and from something complex, go to something simple. So I'm going to go, Picasso is again the person that I'll use. So I'll go in a sequence through what is 11 stages of a lithograph. 1, 2, 3. This is the final one. The interesting thing, I flashed them very quickly for you to look at the dates. The interesting thing is Picasso did it in this order. This was the first, second, third, and this was the last. And it's only when you are here is that you can understand, for example, what it means when he put the handlebars and a bicycle seat together, and he called it the head of a bull. Just that in isolation means nothing, okay? So what I wanted to leave with you, if you don't come from the artistic side of things, is art is a constant search for breaking paradigms. There is no prize for doing something second, okay? Science, and we didn't argue this much, even though I believe that things have the stamp of the person who created a theory, and I will use the word created, although, for example, that stretching and folding thing that I mentioned that I was involved with, that's more like discover. That was there all the time. All what I did was to reveal it, that it was in there and make it clear for others to see. Technology is not inevitable. There are lots of dead branches in the tree of evolution of technology. Science, by the way, has very few dead branches. If a branch doesn't work, it just gets chopped off. The tree of art has lots of parallel simultaneous branches, many of which survive even though they may have not led anywhere. And the other one is technology is more like art. And probably the thing that I want to leave you with is that if you look at most metrics that you can think of, I show a few in what were the sort of secondary notes in this kind of book. By almost every metric, technology sort of falls in between the art and the science component. So that's all that I have prepared, and I will be very happy to answer any questions that you may have. Thanks. Okay, so. Yeah.
I just wanted to hear what you thought about your design policy.
There are a few things that don't fall in these three categories. For example, architecture will fall in all three. Math is a singularity, doesn't fall in any one of these. I think design kind of falls in all three in some way. Design still is a subject where the field dominates the domain still, and will continue to be like that until some parts of the domain get more formalized. And that may be the end of design as we know it, because too much formalism is good to create more people flock to problems once, at least in science, when things are more defined. But the more defined they are, the more carbon copies of people in the field you create, and the more the creativity diminish sometimes until there is an explosion. So I would say design falls in all three. But I think the challenge in design is that some parts need more definition. They have to become more like some parts of design is a little bit like performance art. Someone comes, does something, if the person dies, there is no way to hand those lessons to another people. So I think that there should be some equilibrium on the ability to hand lessons, but not to the point that you fossilize everything. But my attitude is that belongs in parts of those three domains. Yeah.
One area that seems a little bit different, where technology doesn't kind of sit in the middle, seems to be in the sort of size of the groups.
Yeah.
Except for sort of large scientific collaboration. But by and large, science is done in a very small group. Art, similarly, it's individual people. Technology has the teams in the middle.
Yeah, science now is done really gigantic groups. And I'm not talking about particle physics. We just, a couple of weeks, we got two of these DOE centers, stimulus money is 19 million bucks each. The smallest one involves 12 people. The other one is 25. So there are parts of science, especially social science or humanities are, I would say, is the last enclave of single work. But engineering is full of big groups now. Biology is full of big groups. And let's face it, and part of the argument for doing this, the biggest problems that we have to tackle now will require such a blend of talents that having some degree of appreciation how the other domains work, in my opinion, will become a must. Yeah.
Would you argue that there's some changes you can make to how schools are organized or curriculum is done that would take advantage of that?
Well, I'll give you two things, because I have thought about this. I meet with the PhD students in Northwestern. They are organized, which is great, because they are about close to 900, and I get to see like 200 in one shot. And I see all of those brains, but all of these brains are fully occupied working on a PhD thesis. And I know these brains have capacity to do other things, but the major constraint is how the NIH or DOE allows them to deviate from that path. So that problem will be an easy one to solve. The one that is harder to solve, and it has to happen on an individual basis, is on how people get fed into the pipeline of talent in universities through the best high schools. The best high schools determine that you are good in math, so we'll try to give you more of an option to become better. And at some point you bifurcate, unless you really work hard. You bifurcate completely from the guys who are determined to be good in poetry and visual arts, and you start going through this diverging path. And then you get these people who are pre-filtered to you, where it will be much better to have people who have both things together. So I do not know how to solve that one through public policy, but the PhD issue, so it happens that one of our alums is now the guy heading the Science and Technology Committee in Congress, so NSF falls under him. I'm dying to be able to talk with him, because I think that you will attract an even broader variety of people doing PhDs in anything if you are telling them, look, for 6 months, You can take time off and do this other thing. And in fact, it's mandatory that you do so. We don't get to use all the brain capacity in all the universities because most people cannot do it. If you are funded by the Department of Defense, you have to work on this, you have to report how many hours you work on with, and that's it. There was something else somewhere? Okay, so I guess that's it. So I want to thank you, okay, for your attention. Thank you.